All right, so here's a video to go with a worksheet. And so we're taking 3,822 divided by 14 using the traditional algorithm. So 14 doesn't go into 3, 14 goes into 38 twice, so you put a 2 above that place value. Multiply and subtract and bring down. All right, and then you're like, okay, 14 goes into 102 how many times? You might not know, so you might try 8 on scratch paper. Again, 2 and 3, and you're like, ooh, that's too much. So then you might try 17, 14 times 7, 28, bring over the 2, you get 98, and you're like, oh, that works. So you're going to put a 7 above the 2, and then 7 times 14 is 98. Again, some kids might add on and get 4, other kids might ungroup, kind of up to them. Bring down the 2. Again, if kids know 14 times 3 is 42, that's helpful. If not, they might do it on scratch paper. All right, that's the standard algorithm. All right, let's do scaffolding. So say I have 14, again, going into 3,822. So 3,822 goes in the house divided by 14. So in this method, we kind of do groups of 14. So a kid might start with 10 groups of 14, and they might write 10 groups of 14, or they just might write a 10 off to the side. So 10 times 14 is 140. Again, they're only going to use numbers that they can do in their head. So when they take 3,822, they subtract their 140, they get 3,682. And so then they might realize that's going to take me forever. So then they might do times 100. And again, they might write 100 groups of 14, they might not. Subtract 1,400. And again, let's see, it doesn't look like we have to regroup or ungroup. So 2,282. Again, they realize that would work again, so they're going to do 100 groups again, subtract 1,400. Again, they might ungroup, they might not show it, 882. And so at this point, they're like, okay, well, I can't do that anymore. Some kids might do 50 if they recognize that half of 1,400 is 700. So they wouldn't take 50 times 14. That they would not do. But they might recognize like, oh, if 100 is 1,400, half of it, 50, would be 700. They might do that. But they might not. So if they don't do it, they might jump to 20 because they might just double their 10 groups. So if they double their 10 groups, they would subtract 280. And then they might do that again. 20 groups, subtract 280 again. And that's like, what, 322. And then they might do 20 groups again and subtract another 280. And then they're going to get that 42. And again, I'm guessing most kids don't know 14 times 3 off their head without doing scratch work. So that means they would probably just do 2 groups of 14. Doubles are kind of primitive. Most kids know their doubles. That would be 28. And they're going to get, what, 14 left, and then one more set of 14 would get them to 0, okay? So again, we want to do this the way kids would do. So then these are the number of groups of 14. So we're going to add those up. So we have 100, 200, 260, 273 right there. So we still get the same answer. The kids, notice they didn't have to do any scratch work. They just kind of, you know, kept track of numbers they knew and then added up the number of groups. All right, method C is kids are going to do 14 times a bunch of stuff, and their goal is to build up to, they want to build up to, what is it, 3,822. So this is their goal, is to get up to this number. And it's kind of like backwards scaffolding in a way. They're going to multiply as much as they can to get up here, but they're also going to use addition. So we're going to have to think a little bit more. So a kid might multiply by 10 first and be like, okay, well, I'm up to 140. We got a ways to go. Multiply by another 10, that would get them to 1,400. They're like, okay, well, we're getting closer. And then they're going to maybe multiply by a 2. And let's see if they multiply that 2, they're at 2,800. So then they're like, okay, well, I'm pretty close. So now what they're going to do is add on from there. So they don't ever subtract. They won't subtract these. They just have that 2,800, and they're going to add on. Now, be careful. So far, all we've done is multiply. So 10 times 10 is 100, times 2 is 200. So right now, do you guys see there's 200 groups of 14. And now we're going to add on individual groups. Okay, so I have 2,800 and we need to add on here. So a kid might be like, okay, well, 10 groups of 14, I can do that. So I'm going to add on 140. So that's 2,940. And then they're like, okay, I could probably add 20 groups of 14. And notice we're adding here. So 20 groups would be double that, 280. That's what, 12. So I have 3,220. So probably another 20 groups. And again, if you go over, then, you know, you need to lessen up what you're doing because you're trying to build up to this number. So that's another 280. So 3,500. Again, they might try another 20 groups of 14. So 280 again is 3,780. We're getting closer. All right, so now it's, you know, kind of dangerous. They look at 10. It's like, ooh, I think that's going to put me over, right? So, you know, maybe they're trying to play it safe. So let's try. We have 3,780. Let's just add two groups of what? Two groups of, what are we dividing by here? 14. Okay, so two groups would be what? 28. So let's see what that gets us. 3,808, that's getting better, and maybe one group of 14, which is 14. So we get a 2, 2. Oopsie, this was a 7. Oh, that was an 8. Sorry, can't read my own writing. All right, and so let's see, 2, 2, 8, and 3. Okay, so we multiplied to get it as big as possible, and then we slowly added on. Okay, so what's our answer? Well, we have 200 groups from multiplying, but then how many more groups do we have? Well, you can see there's 73 more groups, and these are adding. These are not multiplying. These are groups that I added on. So I have my 200 groups up here, plus I added on another one. That's where that 273 comes from, 273 groups. All right, and then the next one is using base 10 blocks. All right, so say, and with this one you do always how many in a group. So we have the same number. We have 300, or actually it changed, didn't it? Divided by 3, okay? And so what I'm going to do is I have this many blocks, right? And I'm dividing it into 3 groups here. All right, so I'm going to draw my base 10 blocks. I have 3 cubes because I have 3,000. And then I have 5 flats, and I have 7 longs, and I have what, 6 singles? 5, 6 singles. Okay, so that's my number, and notice I know I'm dividing it into 3 groups, so I'm going to go ahead and put, 1, 2, 3 groups here. All right, so the first thing I'm going to do is I'm going to write the long division process. And so we can see these kind of side by side. Okay, so step number 1, I drew the picture. Okay, and 3 groups. Okay, all right, so does 3 go into 3? Yes, okay, but that's not really a 3. It's really 3,000. So those are really my 3 cubes. Do you see it? I have 3 cubes. They're right up there. Those are my 3 1,000. So I have 3 cubes. Divide by 3. Now, instead of saying does 3 go into 3, it's really if I have 3 cubes, can I divide them among 3 groups? Okay, and the answer is yes. Everybody gets 1. So if you have 3 cubes and you have 3 groups, you can give everybody 1 cube. So that's what I'm going to do. Everybody gets cubes. So these are gone. And notice 1 times 3 is, I use all 3 up, there's 0 left over, and you can see that. All right, so when I bring down my 5, what does that represent? That's the flat position. I have 5 flats, or you can see that's 500. So 100, 100, 100, 100, 100. I have 5 flats. Now, instead of saying, does 3 go into 5 one time? Yeah, it does. What you could say is I have 5 flats and I have 3 groups. How many flats does each group get? So if you have 5 flats and 3 groups, everybody can get 1. So I'm going to give everybody 1 flat. So I'm going to put a 1 in there. 1 times 3 is 3. And when you subtract, there's 2 flats left over. So when everybody gets a flat, you can see there's 2 flats left over. Okay? All right. So when I bring down the 7, that represents Okay, me going into long. So step number 2 is I gave each group one cube and 1 flat with what? 3 flats left over. Now, at this point, you need to convert. So when you bring down the 7, that represents you converting everything into longs, okay? So unconvert, or let's do ungroup. Ungroup the 2 flats into 20 longs plus 7 longs equals 27 longs. Okay, so I'm going to show that in my picture. So I'm going to ungroup. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And you should be able to see those 27 longs there. They're right there. All right. So next step, now I have my 27 longs. And again, instead of saying does 3 go into 27, it's really you have 27 longs in 3 groups. How many longs can you give each group? Well, if you have 27 of them and you have 3, every group can get 9. Okay, that's what's really happening. It's not that 3 goes into 27. It's that 27 can be split among the 3, everybody getting 9. So I'm going to give everybody 9. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so I have my 9. 9 times 3 is 27. You subtract. Okay, and there's 0 left. So these all got given away. Okay, so each group gets 9 longs, 0 longs left over. Okay, now what? Okay, we're going to bring down our 6 singles. Okay, so 6 singles. Okay, and again, if we have 6 singles and there are 3 groups, everybody can get 2 singles. So 6 singles divided by 3 groups equals 2 singles per group. And again, 0 left over. So 3 goes into 6 twice, but it's really 6 singles divided by 3 groups. Everybody gets 2, so I'm going to give everybody 2. Minus 6 is 0. There's none left over. These are gone. Okay, so that's kind of how you do long division. So your answer is this, but why is it? It's because I have 1 flat, 1 long, 1 cube, 1 flat, 9 longs, and 2 singles. And that's kind of how long division works there. All right, I'll make a second video on the next part in just a second.